Today's learning focus is the binomial distribution. And your first word for the day, you won't see it a lot, but you might see it, is Bernoulli. I think I spelled it right. It's sort of like a pasta, but not. So Bernoulli, a Bernoulli event has two outcomes. It's either a success or a fail. It's one or the other. And now we're also going to introduce some little letters to you. So we're going to use the letter N, and that's the number of trials.
That looks like put a bit of sail on it so it looks like an rather than a
Okay, and the letter P is the probability of success. And Q is the probability of failure. What can you tell me about P and Q?
Are they going to be the same?
They're going to be the same? No.
Are they going to add up to 1?
They're going to add up to 1. Which brings me to probably the most embarrassing mathematical moment of my life. So P plus Q equal 1. That's a very important point.
I like trials.
I was sitting in my first year statistics lecture at university, and the lecturer was doing binomial distribution, and he said P plus Q. He was just doing some working on the board, and he said equals 1. I was like, how on earth is that 1? I thought P plus Q squared was P squared plus 2PQ plus Q squared. I just couldn't get it out of my head, but that's true, isn't it? That expands to that. So I was like, how on earth did he get 1? Anyway, so I encouraged him up to the lecture at the end of the at the end of the lecture, and I said, how did you get that? That's 1. He looked at me in a strange way, and he said, well, P plus Q is 1. So 1 squared's, we didn't get into that, we didn't say 1 squared's 1. So it was quite embarrassing, really. I know.
Why do you think P plus Q squared equals 1?
You don't need to worry about that. But what you do need to worry about is that P plus Q is 1. You need to worry about these letters here, they're very important to you now. And we'll give you some more notation too. So I can tell you that I've got a binomial distribution by writing this. We've seen the capital letters before, so we use capital letters for our distributions. So I use a capital letter and I do a little squiggle and I go B-I-N bracket N-P. Or I write it as capital X, little squiggle B, N, comma, P. And this little squiggle, as instead of writing the word distributes, so this reads as X distributes, binomially, it's the B or the bin, with N trials and P probability of, what's P the probability of again? Success. Okay, so that looks kind of confusing, but that's what it's telling you. So if you saw this in an exam question, you know you're looking at a binomial distribution, as opposed to a normal distribution, which we'll see later. Another thing to look at, I'll just move the camera. is if I look at the probability of something happening, so like this in general, there's a little formula, and you can do it by hand, or you can use your calculator to work it out. And xp, I should get this right, x cubed n minus x. So we've seen this before, we saw at the start of the year, and we're going to use it again now. So we called it the binomial theorem at the start of the year, didn't we? And now we'll look at the binomial distribution, so it shouldn't be a surprise that this looks very similar to what we're doing at the start of the year. Looks complicated. Let's have a little example. And let's pick up one from the book so I know the answer. So I want to look at the I'm going to roll a dice.
What page do you want?
I'm going to roll dice, don't worry what page I want you to watch this. I'm going to roll dice 5 times. Okay? And I want to find the probability that I get, exactly 4 fives. Let's see how we set that up. What I'd like to see when you answer these is I'd like to see you doing a little checklist. So here you write down what n equals, you write down what p equals, and you write down what q equals. So n's the number of trials. How many times are we throwing the dice? 5 times. So n equals 5. P is the probability of success. Here what we're looking at is the probability of getting 5. What's the probability we get a 5 when we throw a dice? 1 over 6. So the probability of success is 1 over 6. What's the probability that we fail? What's Q? 5, 6. And then one of the tricky things you guys are going to be writing out what we want to find. We want to find the probability that we get 5 4 times. We want to find the probability that x equals 4. Probably that the thing we're looking at is successful 4 times. I reckon that's going to be the tricky thing for you guys to get out of the question, what to write here. So when I'm looking at success and failure, I'm no longer thinking about 5s anymore. So we can work it out this way. What goes up here? 5, because we've got it 5 times. What's going to go down here? 4. What am I going to write instead of P? 1/6. What am I going to write instead of Q? 5/6. What am I going to write up here? 4. And what am I going to write here? 5 minus 4, or 1. And then I type it into my calculator, and I get as an answer, hopefully, 25 over 7776.
Really quick calculation.
That's a really quick calculation. Quite proud of myself there. And also, I haven't done it, but on your calculator, there's a little cheat on your calculator, if you're allowed to use your calculator, where you could type this in instead to solve it. You type binomial in, which you find in your probability menu, I'm guessing. PDF. What does PDF stand for? P stands for guess, probability. D stands for distribution, and F stands for function. Function. Bracket, and then you
Number of
number of trials, which is 5.
Normal PDF?
the p-value, which is 1/6, and the last number,
X value.
the x value. Good, thanks. 4. So
Right.
the n value, you need the n value, the p value, and the x value. If you're using your calculator, you need to know how to do it both ways. All right, so see if you can do that on your calculator.